So welcome, Prasad.
Good evening. Yes. In the series of a setup approval, today we will come with another topic, that is melting and pouring. So let's move on with the issue. Next. Yes. Right now we are working with the quality assurance, whether it is quality of the product or whether it is quality of the process. We are right now in an assurance phase instead of the control. So setup approval is a pre-production activity to assure availability of required material in required volume and quality, then get real-time awareness of plant conditions and production plans, and first sample inspection and assure that everything is okay and ready for the production. So why it is needed is a money issue, so it is the management scope. How to do is decided by the quality assurance department, and who will do it? Of course, it is the activity for the production department. Next. Yes, why we need the setup approval? Of course, prevention is better than cure. To avoid the loss in a time, to avoid loss in a rejections, to get assurance for production, to avoid post-production activities and non-value added activities due to rejections, and to remove the annoyance in the system. Then it can remove the unplanned activities, so we can plan the activities in a proper way due to setup approvals, to observe changes with respect to control plan and take necessary actions before we get in the full production run. So summing up, avoiding loss in terms of money and ensure quality is a basic need of the setup approval. So where it is lie in IATF 16949, it is 8.5.1.3. That is verification of job setups. So in this phase, we are liable for verifying the job setups, maintain its documented records, use statistical methods for the verification and application, perform the activity and retain the records for the first of or last of part validations. So it depends on process to process, foundry to foundry. Where the setup approval lie in FMEA. So if we are doing the setup approvals, then we can say the detection rank for the 5, that is the problem detection at a source. So we are using the attribute gauge or go no go gauge. The method we are using, it depends on a foundry to foundry, process to process, but yes, we can go up to the 5 rank in a detection with the setup approvals. This is a generalized FMEA for charging and melting process. So here we can say that at the detection column, there are different phases: failure mode, effects, its causes, design control prevention, and current design control detection. So basically, at the 5th point in a detection here, we can say that it is the detection activity, not the prevention activity, because when it happened, we are just cross checking that it has happened, so we can take the actions. So it is the basically detection activity in FME. Yes. So coming to the today's subject, that is melting setup approval. These are the activity details. The responsibility of the melting setup approval is of the melting supervisor, of course. Then the frequency for some point at start of each shift, for some points at every tool change. So it depends on I have already said that it depends on a foundry to foundry, processes to processes. Record retention, of course, it will be in a check sheet form, and record inspection should be done by the production head, what has happened yesterday. Yes. So first one is a get awareness of the day. Melting supervisor must follow these awareness issues. First one is the what planning given by the production head. Then note or instruction given by the production head. There are the specific notes or instructions that should be followed. Then instruction given by the last shift supervisor with his experience in a shift. Something is happening, something is in a good condition, something is in a bad condition, so we have to follow that instruction given by the last shift supervisor. Then planning part, these are the details like part wise detail annexure should be there. Then part name, grade, its chemistry, number of boxes, number of heats, etc, etc. Then special additions stated by the lab for the specific job. Then the raw material trials if there are any. Then raw material issued by the store. So record stop. अंकल जी बाद में आते हैं. Then the check availability for the material. Sir stop कर फोन करी दरवाजा खटखट हो आते. Yes. Then in terms of the material, we should check the availability of the material. Raw material issued by the store, it should be in a required quantity and a required grade. Then the scrap, we should have, or the melting supervisor should have checked whether it is in a required quantity. Then he must do the visual inspection for oil and moisture free scrap material. Then he must see it is properly sorted grade wise. For example, we are separately taking runners and risers as per the grades. Then the alloys and inoculations, it should be in a right type of a material in a proper manner filled in a closed bins. For example, we are storing specifically the magnesium alloy in a closed bin, so it should be in that way. Then the carbon cups in a necessary quantity in a good condition, means damage free, moisture free. Then the temperature tips should be in a necessary quantity in a good condition, same the damage free, moisture free. Then the spectro, availability of the polished paper, argon gas with the required pressure. See, for a day shift, these issues are getting resolved by the time, but these issues get specifically affected in a night shifts. So that should be analyzed in a proper way. Then the testing, chill sample pattern availability, then the micro sample pin, then the tensile rod sample box, or if you have done the core for the tensile rod, it comes in a material. Next. Machine wise, check the equipments. Specifically for melting and pouring, you should have the approval from the maintenance regarding the safety issues and liability of the equipments. So basically cooling system in a working condition, then GLD, panel and display meter working assurance, then the furnace lifting and the exhaust system working. That is the basically part of different check sheet for the maintenance department. But yes, melting supervisor should have seen some of the points from that. Then the electricity consumption at the start of the shift, you should have record the start units to get analyzed. Then furnace lining wear condition should be within the limits. It is as per your furnace. Then the damage, it should be in a damage free and slag free. Then the weighing scales used for the scrap, alloys and a ladle, 3 of them should be in a working condition to get the shift run in a proper way. If there is a contingency weighing scale, then it should be also getting checked. Then the CE meter, it should be in a working condition, and the melting supervisor must cross check it with the spectro reading for the first sample. Yes. There are some points from machine spectropoint die. It should be available with its functionality. Like it should be damage free, and the temperature of the die is at ambient temperature. So if you have set up the 2 dies, 3 dies, then you should have seen that. Then another, and frankly, I have experienced the this actual equipment, that is sample taking spoon. See, you have the C emitter, you have the spectro. We are taking care of that. These are the machines maintained in a proper way. But think or imagine if you don't have the spoon to withdraw on the sample, or when you are taking the sample and your spoon gets damaged and you could not draw on the sample. So totally you are failure, or you have been failed due to that, because there is no another method at that point, so that you can take that 1200 1250 degrees Celsius sample from the furnace. So it is the look by look, it can say that it is a very small point, but yes, it affects the most. Then the spectrometer, you should have been calibrated with the CRM. Then temperature meters available with its functionality, you must have checked that. Then the overhead crane for the pouring, both production crane and contingency crane is in a working condition. Then for a ladle, it should be red hot. If not, then preheat. Then ladle lock is in a working condition to avoid any accidents. Then the lining is damage and slag free for the ladle. Lining should be in damage and slag free. Then the pockets or parting wicks, specifically who are making the SGINs, it should be in a good condition, and ladle cover is available there only. Then inoculating metering pot or a device, if you are using the spoon metering pot specifically, or volume type machines, then it should be available in functionality and also cross check. Then time buzzer or decremental timer that we are using for a pouring time, and to get that total pouring is within the 7 minutes, so it should be in a working condition and calibrated by the regular hand watch, or we can say the mobile watch before the shift. Then comes with the method point, that is additions and properties. Yes, the charge mix addition sequence, it should be as per the SOP given by the QA department. Then the charge and alloy quantity, it must be as per grade and calculation sheet. Then cross verification of calculated charge mix with the actual chemistry. State issues in a material quality like elements, recovery, size, keep aside the lot or a bag if issue. Here I have to put on the focus, like we are taking the calculations with arbitrary recoveries that we are using in a standard. For example, in a GPC, we are taking the 90%. If your incoming raw material says by the TC that you have to take 90% recovery, and you are not getting that, it is somewhere about 85%, then you have to highlight that issue, that for this batch, for this lot, I am getting it at 85%, so that necessary action can be taken by the QA or a production heads. It is not job of a melting supervisor to take the action. It is his job to inform their upper hierarchy that what is happening on a shop floor. If not, they could not take the necessary actions. He can separately keep that lots aside, that these lots are problematic. So this is basically main activity to control over the suppliers. Then sample withdrawing temperature. Of course, it is as per SOP, foundry to foundry varies, job to job varies. Then slag generation as per your foundry norms, at what quality scrap you are using, and slag generation is stated it should be in a that percentage value. Then the ladle behavior, it should not be in a fluttering. Then the treatment light in a proper, it is treatment light illumination, its sound, its vibration. It is generally experienced thing, but yes, you have to monitor that to get the assurance of a thing. Also the treatment time, at how much time the treatment going to happen. Then the temperature drop, tapping to first box to last box, standard as per the respective foundry. You have to monitor that temperature drop. Then the addition and properties, again for the method. Specifically, we will talk on the pouring. First one is the mold box, whether there are necessary mold box are available or not. Then we can start the pouring only. Then box pouring time, what annexure says and what is actually happening. Then the total pouring time as per annexure, in which time the total pouring should be finish up. Then the pouring temperature range that is given by the annexure, you have to monitor that. Then amount of a liquid metal as per annexure, yes, the ladle weighing scale is giving that. Then the pouring height, there should not be splashing, there should not be leakage of the mold box, then no sprouting while pouring, then streamlined pouring, then you have to ensure the liquid and solid slag, then evenly and without damage filter lifting. Here again, we can say sometimes we get the damaged filter, or we can say poor strength filter. So where to conduct that, or where we would get that the filter are not working. So uplifting of filter, it should be evenly, not the filter should not rotate, and it should not get damaged with that flow. So production department can also ensure these activities to the development department, that or the development department regarding the use of the filter or choosing the filter. And also they can inform to the incoming quality inspection that filters are in a not proper way or not in a enough strength. So for that filter lifting, then the sleeve burning without fluttering, that is it should be in a moisture free. Then inoculation addition assurance. Then the sample castings, if there are any, separate pouring temperatures, times, and spectral point should be withdrawn for the sample castings. Yes. Then job specific requirements. If there are sometimes there are the job specific requirements rather than the regular practices, such as special alloy, if any, with respect to type and quantity as per job wise annexure. For example, we can see here the copper additions. It differs with customer to customer and job to job as per the requirement of the customer. Then weight on a box. Sometimes we need to put on the weights, assuring that then it is specifically seen in a ARPA lines. Then specific temperature requirement as per job wise annexure, of course. Then the repouring if needed. It is not recommended actually in a development, but if you are in a ARPA lines, or we can say the hand molding, yes, it is necessary in a repouring. So as per job wise annexure, you have to monitor that. Yes, from my side, you have to take care of your foundry for your better future. Yes, at Dynamic Foundry Group, we have the experts and youth energy. So get connected and give your all of. Thank you. Yes, sir. Hello. Hello. Hello.